Hey guys, we're going to look at our target 1.4, and here we're going to use proportions to solve for the missing side of similar figures. So just looking at 1.3, we were given two figures and we were told, we would be given all of the lengths and told to find out if they're similar. Now we're just doing the opposite. We're going to be told they're similar and we're going to find out what some of those lengths are. Okay? So let's look at an example. We're given triangle TSU, and I'm missing an S in here. Sorry about that. There isn't supposed to be an S there. Triangle TSU is similar to triangle ESF. Solve for X. Okay? So I like to say the number of my triangles, triangle 1 and triangle 2. Then I have to choose a side. I always start by choosing the side where there's a variable. You don't have to do it. I just think it's kind of the easiest way to make sure you have your variable. So I'm going to choose this side right here because it has an X in it. Okay, and that's side SU. And just like everything else we've done, we're going to compare this, right? This is in triangle 1, and we're going to compare it to triangle 2. Okay, so if I look where S and U are, S and U is going to go with S and F. Again, I want to use the names to double check which sides go together. Okay, so be very careful that you're checking your sides. So this is going to be 5x minus 10 over 24. And again, this is from triangle 1, and this is from triangle. I knew that was going to be bad. Nope. Right? So triangle 1 and triangle 2. Now, proportions, exactly what we've done before, we have another side, right? So the only other side I have in this triangle is this 50, which is ST. Okay, so that's going to go with E and S. Again, those are in the same place in the name. And that's there. And again, I want to make sure I do triangle 1 over triangle 2. And I can, again, what this part tells me right here, that they're similar, tells me that these fractions are equal. Let's try that circle again. Okay, so it's always triangle 1 on top, triangle 2 on bottom. It doesn't matter which one's triangle 1 or triangle 2, but as long as once you label them, that you kind of stick with it, right? So once we have that, this is exactly like what we did in target 1.1. Okay, now we're simply going to cross multiply. I'm going to make sure I put (5x minus 10 in parentheses) times 15. We have 24 times 50. And again, what that target 1.1, that cross product property tells us is that those are equal. Distribute. So 15 times 5, again, feel free to use a calculator. For sake of time, I'm simply going to just tell you what the answer is. But again, if you need a calculator for any of these steps, feel free to use one. So we have 15 times 5 is 75x minus 150, right? And 15 times negative 10 is minus 150. Again, this is a minus, so this is still minus. Okay, so that doesn't change. Equals, and 24 times 50 is 1200. Again, we're solving for this x. So I need to add 150 to both sides. So I now have 75x equals 1350. Again, I'm still solving for this x. So I'm going to divide by 75, divide by 75, and I get x equals, and 1350 divided by 75. I would expect you need a calculator for this, but again, for sake of time, we do get x equals 18. I believe that you can type that into a calculator. Okay. So this is kind of just putting some of these things we already know together, right? I already know I can create proportions with sides of a triangle. I already know how to solve proportions. So we're just doing both of those now. Okay. All right, let's look at another example. Example 2, given triangle JKM is similar to triangle QST, solve for x and y. Okay. When we're solving for x and y, this is two separate equations. So I have to do basically two problems. So I'm going to start with x. X is here with KM. And that's KM. And KM is going to go with ST. Okay? So now if you looked at this picture, you might not have realized that those sides go together, and that's why it's super important to use your name of your triangle. Okay, so it's going to go over 3. And so now this is triangle 1 and triangle 2. So now I need to choose another side to make a proportion. Well, I could choose 3y minus 2, but that would just introduce another variable. I can't do y yet. So if I can't do anything with y, that means I have to choose this side that has a 4. Okay. I'm going to do 4, and that's JM. So that's going to be Q and T. Okay, so Q and T is in the same spots as J and M. And again, what this similar symbol tells me is that these sides are proportional. So I can set them equal. So I'm going to cross multiply. So I have 6x minus 3 times 2. And 3 times 4. And those are equal. Distributing. 2 times 6x is 12x. 2 times 3 is 6, and it's still subtraction. And then 3 times 4 is 12. Again, I'm solving for this x. So I'm going to add 6. So I get 12x equals 18. I'm still solving for this x. So I'm going to divide by 12. divide by 12. And 18 divided by 12 is 1.5. You could also get that as a fraction. Again, either one is fine. But again, once you have it set up, it's exactly like what we did in target 1.3. Okay, now we need to solve for y. So we have this side over here. This is my side that has the variable I'm solving for. And that's this piece here, JK. And in the same spot is QS. Now again, I need to choose one other side. So again, I could choose the 6x minus 3 or the 4. I'm going to choose the easiest one. I'm going to choose the 4. And as we already saw, 4 goes with that too. Okay. And again, because they're similar, those are equal. Then we just pretty much do the same thing. So we have 3y minus 2 times 2 equals, and that's 5 times 4. Okay. Make sure we distribute. 2 times 3y is 6y. 2 times 2 is 4, so we get 6y minus 4. And 5 times 4 is 20. Add 4. Oh, wait, yep, because we're solving for y. We're going to add 4 to both sides, doing the opposite. So 6y equals 24. And again, we're solving for y, so we're doing the opposite. We're going to divide by 6. So y equals, well, 24 divided by 6 is 4. And that's it for example 2. Let's look at our next example. Example 3. Example 3 is given triangle ABE is similar to triangle ACD. Solve for y. Okay, so when you have this, what we really have is one triangle like on top of or inside of the other. So let's look. The first triangle we have is ABE. And the second triangle we have is triangle ACD. Okay, so we have this blue triangle and this green triangle. Okay? I think one of the easier ways to do these problems is to just split it up. So I'm going to draw my blue triangle here. That's A, B, ooh. And what sides do I know? I know this side is y, and this side is 5. Then my green triangle well, again, this one side is easy. It's just 20. I'm going to use the dark green to kind of show what that is. This side is more difficult, okay? Because this piece here is y, and this piece here is 4. So what I have to do here is I have to go y and then go another 4. I'm sorry. So really what this side here is y plus 4. Okay, so be careful when you have those pieces. You do, if you want to go the whole length here, you have to add them together. So again, with this problem, anytime you have something that looks like this, or when you have something that looks like this, you can separate it into 2 triangles. So now let's set up our proportion, right? I want to start with the variable. That's usually where I like to start. Well, I have a variable here and a variable here. It doesn't matter which one you choose. It's just like good strategy to start with like a variable. So whichever one, let's start with our y. Why not? And y is between a and e. So that's going to be compared with AD. Okay. This one's not too difficult because like the sides that go together makes sense that they go together. But again, it's good practice to always make sure your pieces are matching up. So then the only other side we have is 5, which is EB. And that's going to match up with DC. So we're going to put 5 over 20. And those are equal. Then we just cross multiply. So here we have y times 20. God, I haven't used it. And we have y plus 4 times 5. And then we get 20y equals, again, making sure we distribute, we get 5y plus 20. So now again, we're solving for y, but y is in 2 places. So again, we did some of these in target 1.1. When y is in 2 places, we subtract that whole term from both sides. A lot of you guys don't write the y here. It is proper notation and proper math to subtract that whole term. That's actually what you're doing, and I'm going to be very, very picky because if you continue on into like pre-calculus and AP calculus, the problems are easier if you like really practice your notation and those like little specific things now. Okay, so I am gonna be like really picky on like homework and stuff that we have like correct notation. And you'll probably have already seen that if you've looked at your feedback from last week's homework. Okay, so 20y minus 5y is 15y. These cancel and we're left with 20. Then again, we're solving for y, so I'm just going to divide both sides by 15. And we have y equals, well, 20 over 15, if you write it as a fraction, it's 4/3, or approximately 1.3. Okay. Again, I will accept either of those answers, either y equals 4/3, or y is approximately 1.3. All right, the last thing we're going to look at is just some word problems. So looking at example 4, at a certain time of day, a 1.8 meter tall person standing next to the Washington Monument casts a 0.7 meter shadow. At the same time, the Washington Monument casts a 65.8 meter shadow. How tall is the Washington Monument? Okay. So I'm going to draw this. Here's my person. And then shadows are on the ground. It's a big thing. A lot of times we try to put shadows in the air. Your shadow's always on the ground. Okay. That's just my dog crying because he's not able to go outside. So if you hear a high-pitched squeaking, that's what it is. All right. Then we have our Washington Monument. That's a beautiful Washington Monument, if I do say so myself. I am not artistic. I can't draw. So I always try to draw pretty pictures for word problems, and they always look horrible. But just pretend that that's the prettiest Washington Monument that you ever did see. And the Washington Monument will have a shadow as well. Okay? So I'm going to try and put in some of these pieces. So we have that there's a 1.8 meter tall person. They're 1.8, right? That's their height. Standing next to the Washington Monument, casts a 0.7 meter shadow. So their shadow is 0.7. At the same time, the Washington Monument's shadow casts a 65.8 meter shadow. Okay, so they're so 65.8. How tall is the Washington Monument? So that's right. What the question is always what your variable is. Okay, and this is going to create a similar triangle. I could put like a line here. And if I drew better, those would be similar. But we're going to pretend these are two similar triangles, right? So the shadow of the sun always creates like similar triangles because it's like always the same angle that it's hitting people at. So what we have here is really, again, I can start with my variable. So I have x over 1.8. And so if I started here with x, I need to start here with 65.8. 65.8 over 0.7. And again, those are equal. Cross multiplying, I have x times 0.7 and 1.8 times 65.8. And again, these are equal. So I have x times 0.7 is simply 0.7x equals 1.8 times 65.8. When I typed it into a calculator earlier, I got 118.44. I can pretend like I'm just doing it in my head, but I'm not. Solving for x, so I'm going to divide by 0.7. So then x equals, and again, when I typed it into a calculator earlier, I got 169.2. And then we want to make sure we put a unit. That lets me type in m ever meters. Okay. All right, one last word problem. So here we go. Before rock climbing, Darius needs to know how high he will climb. He places a mirror on the ground 34 feet from the base of a cliff. He then walks backwards until he can see the top of the cliff. What is the height of the cliff if Darius is 5.5 feet tall and is 6 feet from the mirror? So I have a cliff. Here's my cliff. Okay. He places a mirror on the ground. Here's a mirror. And then he stands somewhere like here. Okay. And what happens here is, again, this creates a similar triangle because when you look down at a mirror, you like bounce back at the same angle. So you get like your little congruent angles there. Okay, so and this situation also creates these similar triangles. So again, I want to put in the information I know. So, he places a mirror on the ground 34 feet from the base of a cliff. The word base means bottom, right? So this distance right here is going to be 34 feet. He then walks backwards until he can see the top of the cliff. What is the height? Darius is 5.5 feet tall. So he's 5.5. And he's 6 feet from the mirror. So this distance here is 6. Okay, so again, I'm looking for what is the height of the cliff. Okay. So again, I'm going to do x over 5.5. Buick. He likes to eat my pens, so he gets in trouble a lot. And then I have, so I started here with x, and then so I have 34 over 6. And these are equal. I'm going to move this up just a little bit. Now that we don't need the word problem part, we can just show the math. We're going to cross multiply. So we have x times, he tries to jump up on the table next to me and then gets stuck and moves the whole table. X times 6 and 5.5 times 34. And those are equal. Oh my gosh. 5.5 times 34, not 5.5 equals 34. And those are equal. So now I have 6x equals 5.5 times 34 is, again, when I typed it into a calculator earlier, I got 187. And then I'm solving for x, so I'm going to divide by 6. And I get x equals 187/6, which is approximately 31.2 feet. Okay, and that is it. I will see you guys later. If you have any questions, let me know.